Hey everyone, and welcome to this series where we are going to be exploring and creating some sample implementations for some of the most commonly used OpenZeppelin smart contracts. In case you're not already familiar with OpenZeppelin, they've been an absolute leader in the Web3 security space for quite some time now. They've audited some of the top DeFi protocols that are out there. They created the Ethernaut project, which is a great way to practice smart contract auditing if you're just getting into that. And also, they provided a whole suite of smart contracts to us that are fully open source and usable in our own contracts. And that suite includes supplementary kind of security features as well as just default pre-made implementations of some common ERC standards like ERC20 tokens, liquidity pools, governance, etc. So to get started here, we'll just go over to the products section and click on contracts library. That's going to go ahead and bring up this contracts landing page. They have a kind of cool interface here where you can actually select some of the most common ones and then begin customizing it using this graphical interface. So that's pretty cool. We're going to go over to the actual documentation page though by clicking on the Start Coding button. And today we're going to look at a contract from the access control section called Ownable. So it's a very common thing when you're securing smart contracts that you want to make sure that any function that's performing any kind of sensitive state change is essentially protected in the sense that only privileged addresses can invoke those functions. So it's a relatively simple thing, but why take a chance implementing ourselves when we can just go ahead and use the OpenZeppelin contract right out the box. So you can see in this code snippet here, once you extend Ownable, then you can go ahead and call the constructor, passing in this initial owner parameter, and then whatever functions you apply this only owner modifier to, that means only the contract owner can invoke those functions. So we're going to make a very similar implementation to this code snippet, but we'll take it one step further by running a series of unit tests against our contract, and that'll provide, I think, a good way to kind of dive deeper into the contract and see what's going on behind the hood in this ownable contract. So to get started, first of all, you're going to need the OpenZeppelin contracts so that you can import them into your own contract. Also, to run the unit tests I'm going to show in this video, you'll need the hard hat framework. And in case you just want to kind of browse through the full contract code without actually installing or importing the contracts in your local project first, just go ahead over to the OpenZeppelin GitHub page and you can view all the contracts here. Otherwise though, let's go ahead and get started with implementing our own contract. So we're going to call this contract with owner. So contract with owner. And then it's going to extend the ownable contract. We're going to define this contracts constructor with no parameters, but because we're extending Ownable, we will need to pass that parameter here, initial owner, to the ownable contract. So we're going to make sure that the contract deployer is the initial owner by passing in message.sender, and that takes care of the constructor. Next, to kind of illustrate the point here with the protected versus unprotected functionality, we're going to make two state variables. We'll have a uint public protected count, which is going to default to 0 because there's no value being set here. But then we'll have an unprotected count. Let's copy that down. Next, we'll make two setter functions with the same idea in mind. So we have function protected function. We're going to pass in the new count. This is the one we want to protect, so therefore we're going to use the only owner modifier. You can see it's already populating into code completion because of it's being imported from, or rather included in the ownable contract. And then it's going to be external, and we're just going to simply just overwrite the value, essentially reassign the value. Okay, go ahead and copy this one down. And we'll first rename the function to the unprotected function, and we'll remove this only owner modifier, so therefore any external account or address can go ahead and just invoke this function. We'll make sure we're updating the right state variable, so unprotected account. And that's pretty much it for the contract itself. Now I already went ahead and set up all the unit tests ahead of time to save time in the video here. So basically we have the deployment fixture, so we can set up everything before running the unit tests all in one place. First test is going to make sure the contract deployer is indeed the owner. That address should be able to call the protected function. Any other address should not be able to. Anyone should be able to call the other function though, the one that's not protected. This is an interesting one. So if someone tries, or if the owner rather tries to transfer ownership to an address or the zero address, in other words, an invalid address, it should revert. So let's go ahead and actually pull up the code for the ownable contract right now. This is purely based on intention. So you have two functions here. You have renounce ownership and transfer ownership. So when you're calling transfer ownership, obviously the intention should be to transfer it to a valid address that can therefore take control of the contract. So the only invalid address, theoretically speaking, would be the zero address, since that's not an accessible address by anyone. So therefore, it's going to revert if you try and do that. But if you want to renounce ownership, the only way to really truly do that is to transfer ownership to a zero address. So we have tests for both of those here. We should be able to successfully transfer ownership to another address. And then the new owner should be able to call the protected function as well. And then a non-owner should not be able to renounce ownership, but the owner should be able to renounce ownership and therefore have the zero address become the new owner. And as you can see here, it's exactly what's being tested. The new owner should be the zero address. So let's go ahead and run these unit tests now. And I would definitely encourage you to go ahead and clone this repo. I'm going to put the link down in the description. You can run the tests yourself, tweak things, experiment, and so forth. But here we go. So we're going to do npm run test ownable. Okay, so everything passed. Yeah, if you go ahead and run these tests some other time on your own, if you feel like it, then you'll be able to kind of more closely check out and inspect the console logs and just play around with things. But in any case, that's it for this one, and hope to see you guys in the next one.